We're going to be talking about Terraform and Serverless tonight. Specifically, I want to talk about how we can manage complexity, reduce tech debt, and ship safely and regularly. And that's the main reason that we get paid, right? How do we ship safely and regularly? I want to kick off with a little bit about serverless, why you would use serverless, how serverless compares to other compute models. I've blocked up this little diagram. We could probably argue about this all night. Everybody has probably heard the phrase pets versus cattle. I've knocked up this quick chart of various computes and where I feel they sit on a matrix of the heterogeneity of workloads that they can run on one side versus how simple they are to operate. So obviously, if you're running on bare metal in a data center or in some sort of IoT device, you can run whatever you like. You have complete freedom.
Sorry to jump in there, Mark. Are you able just to adjust the mic, just so you're getting a little bit of feedback, I think, from it. The mic on your shirt.
Yeah, is that any better? Am I belting through? Am I?
Yep, that's perfect. Thanks, mate.
Yeah, so from bare metal to platform as a service, where I see AWS Serverless sort of sitting in the middle of that matrix. So you've got things like EC2 and infrastructure as a service that's seen as a bit legacy these days, but still has its use cases. If you wanted to run some obscure database, for example, that didn't have a managed instance available, you might look at running on VMs or infrastructure as a service. Containers and Kubernetes and things like that sit in a nice sweet spot. You can run just about anything you'd want, data processing, web apps, even simple websites if you'd like, on Kubernetes ECS. And then on serverless, there's a little bit less to run, or quite a lot less to run. But your options are narrowed a little bit again. So if you wanted to run anything that had an identity, for example, like a Kafka consumer or a potentially even Cassandra nodes, or things like that actually have an identity, you'd struggle to run those in a serverless model. And then, of course, at the far left of the scale, you've got platform as a service where you don't really care. You don't have to worry about anything at all. It's a true no-ops model. I want to look at the promise of serverless because I think a lot is made of it. And I think as developers, we don't always deliver on that promise. And that's a lot about what this talk's going to be about. So the promise of serverless is that there's nothing to operate. Literally, you don't have to log in and check if servers are up, how your auto-scaling groups are doing. And off the back of that, you have massive scalability with ease, per-use billing, which in theory should give us faster time to market, which is at the end of the day, what we want: developers, products, delivery, faster time to market. That's the goal. That's why we're here. The thing standing in our way is the complexity of production-ready systems. I think, or at least for me, coming into serverless, I don't think a lot of people are prepared for how much stuff you still have to do. So that while there's no physical hardware to operate, there's still a whole bunch of complexity that has to be dealt with. And I want to look at that. I want to look at that now with a sort of a typical example. I want to imagine that we have some microservice, some little web app that consists of an API gateway, some compute, a lambda function, for example. Sorry, guys. I should add it as an aside. EqualExperts have this amazing audio-visual kit. So I've spent the last hour setting up just to get the room having this lovely look about it. And one of the LED lights has just fallen off my makeshift stand. Back to my example. So we've got an API gateway, some sort of compute, which will probably be a lambda function when we're in AWS. Some sort of state store, which will probably be a DynamoDB table in the serverless world. And let's imagine we have some channel which we can broadcast our state change to our wider microservices estate. In this case, the example is an SNS topic, but that could just have easily have been, say, Event Bridge. And these are the logical elements. that would sit in a typical serverless example. In actual fact, when it comes time to provision this infrastructure, and this is the absolute bare minimum infrastructure, you've got provision around 13 actual AWS primitives. And the majority of that actually is IAM. So giving permission, for example, for the API gateway to call the lambda function, permissions for lambda to publish to SNS, and permissions for lambda to speak to Dynamo. API gateway itself is a bit of a pain to provision. So 1, 2, 3, 4, 5, 6, 7, 6 or 7 API gateway resources just to get this fairly simple example set up. That only gives us the bare minimum. So Google published a paper a couple of years ago now called The Hidden Technical Debt in Machine Learning Systems. And they have a really nice little graphic that shows a small black box in the middle. That's your machine learning code, and all of these peripheral concerns on the outside. This is my version of it. This is my poor man's version of this. So if you can imagine that we have our application code, and this is what the business is concerned about. This is what we want to deliver. So when we pick up that Jira ticket, this is the output. And then we have all these other concerns sitting around the outside: monitoring metrics, alerting, any various supporting infrastructure. So in the example that I used before, we had a DynamoDB database, had SNS topics. We also need to make sure we can log, we can query those logs, IAM permissions, so what services can access what resources. If we're in microservices world, we want some distributed tracing to follow the code path through our entire system. Ideally, we want some compliance tools. So that can be things such as AWS Security Hub that monitor the security, the state of your system in AWS. I'll touch a little bit more on compliance later on. Hosting, it's fairly easy in the serverless world. That's going to be Lambda. Reporting, analytics, and ML is often an afterthought for software engineers building digital platforms. So if we've built this lovely web service that is taking customer orders, for example, and the business says to me, well, can you run me a query on how many orders for customer ID 7 were dispatched in the last 3 weeks? DynamoDB is not going to help you there. So how do we satisfy that concern for the business when it invariably comes up? Good news is there are loads of AWS tools that we can lean on to do this for us. Touched on a few of them here. So for logging, monitoring, and alerting, we can use CloudWatch. Obviously, identity management and IAM. Incidentally, identity management and IAM tends to be what a lot of people get caught up on in deploying serverless applications. It's really, really not trivial inside AWS. AWS have a great product called X-Ray that if I have time, we'll do a bit of a deep dive on later on towards the end of the talk. Reporting and analytics that I mentioned earlier. There are tools within inside AWS to make sure your data can get out to things like S3. Once you're in S3, you've got great AWS tools like Glue, Athena, Redshift, or it's even fairly trivial to pipe that data into something like Snowflake, which again, if I have time, we'll have a look at how Terraform can help us do that integration between our serverless services and something like Snowflake. Compliance, security, APM, Lambda Insights isn't really an APM tool, but it satisfies that similar use case that an APM tool would satisfy. And encryption, again, often an afterthought, but are we encrypting all our data at rest? And so we had a really simple service before that just consisted of 3 or 4 elements: an API, a Lambda function, a database, and somewhere to publish that data. Now, a production-ready service may look a little something like this at the end of the day. I don't want to go too far into this. It's a fairly complicated diagram. But you can see, for example, everything with a little red key underneath it is being encrypted by KMS. And then encrypting things with KMS isn't all that trivial, because then you need to make sure anything that uses that service has the relevant IAM permissions to that KMS key. We have our CloudWatch rules and alerts. We can pipe them off to a great little service that I've started using recently called AWS Chatbot that integrates well with Chime, which I haven't used, but quite nicely with Slack. and it'll alert you when you have when your alert rules are fired, and then let you just via Slack check the CloudWatch logs to try and diagnose that just from Slack, sort of level 1 support kind of setup. It's also possible to, with something like Kinesis Firehose, to send those events that you're publishing, with the intent of sharing that state with your other microservices. You can fan those data out with SNS or with EventBridge, something like Firehose, and deliver them to S3, for example. And this is what the complexity of what a production-ready service might look like. The worst news is that every yellow arrow in that is something that requires some sort of IAM setup. And as I was saying earlier, IAM is non-trivial and really error-prone. And again, this isn't even the bad news. I think this is the really bad news. So if you have one service that looks like this, then your whole microservices estate may end up looking something like this. So the point of this section is to talk about the complexity that is involved in delivering microservice systems on AWS Serverless. Now, I think I have a solution for managing complexity, and I want to have a little look at that now with a tool called Terraform. So Terraform is an infrastructure as code tool. Terraform basically, at its lowest level, consists of two types of primitives, a resource and a data source. Resources create infrastructure. So in my example on the left here, we're creating a shopping cart event queue. So some sort of SQS queue that we can pipe into our lambda functions to handle those events. And on the right-hand side, we are looking up an SNS topic. So data sources are something that can go out to AWS and say, hey, can you give me back the details for an SNS topic that has this name? And these are the two basic primitives of Terraform. And what I really want to try and explain today is from these two primitive types, how we can build systems like this. So this was our typical example. This was our prototypical example that I showed earlier. So what I want to do now is a little live demo. This is the Terraform from a service that may look like our prototypical example. So I have my lambda function. It's going to create a lambda function and a role for that lambda function, an IAM role. Creating a dynamo table. I'm giving that lambda function the relevant permissions to be able to access to read and write from that DynamoDB table, and an SNS topic to publish events to. I'm giving permission for the lambda function to publish events to that particular SNS topic. And then I don't really want to deep dive into this, but you can see the configure API gateway. To configure API gateway for that service is a bit of a pig. And as you can imagine, this stuff is really, really, really error prone. And if you're going to be doing this, and this is the bare minimum, this is the bare minimum so that we can build this. This kind of stuff's really error prone. So what I'm going to do, hopefully, is apply this Terraform. So what's happening now? Terraform looks through all of my entities. You can see I have dependencies in between resources. So to give you an example, this lambda function has a dependency on this role. So I create the role, I create the lambda function, and Terraform's smart enough to do like a DAG, right? A graph that says this function has a dependency on this role, so I need to create this role before I create this function, and so on. Terraform apply shows me all the resources that are going to be created. And I'm going to go ahead and create them. Hopefully this all works. Great, which gives me my output of my API, little hello world service I can call over and over again. I have a little counter in that service just so you can see that I haven't cheated. It really is stateful. It's remembering every time that I make that request and just incrementing a value in a database. So this is Terraform 101. To deploy that service that has almost no functionality and you would never want in production, it doesn't even have logs, right? So if I was to look into CloudWatch, this function isn't even logging anywhere. It's doing nothing. So we've got, there's 160 lines of code to deploy something that you would not want to deploy into production. This is low value stuff as far as the business is concerned. So how can we use Terraform to get a bit more value out of our serverless estate and deploy something like this? Well, we have tools for this already in the software engineering world. I found these two quotes because you've got to have quotes for a talk. It's always possible to add another level of indirection, which is the best part of the funniest RFC I've ever read. And that Henry Ford, this is a good quote actually, nothing is particularly hard if you divide it into small jobs. And these two quotes can be spoken about in two other ways that we know really well in software engineering, and that is abstraction and composition. I'd argue that these are the two basic building blocks of writing good software, whether you're using object-oriented code or functional programming or even imperative code. Abstraction and composition are the key to making your life easier. So let's look at what the constructs are in Terraform to enable us to have this abstraction and composition. Terraform has this concept of modules. These are like libraries in the software engineering world. So we might create a library that is called, for example, SNS SQS subscription. So I have a simple Terraform module here. All it does is, when it's given a SNS topic name and a queue name, it will create a queue and subscribe that queue to the SNS topic. And it looks really basic, and it is really basic. But I think that's the strength of it all. And so then when we want to use this module, this window on the right here is how it might work. So this Git repository doesn't actually work. We say, here's the source of, so this Git repository doesn't really exist. We say, here's the source of my module. Here's the variables that you're asking for. Go and create me this stuff, okay? Again, this is really basic, really, really basic stuff. I don't know if anybody can hear that. Some gunshots going off in the park across the road. And this is how you would use this Terraform module in your code. So you can see instantly that just with this one layer of abstraction, we've abstracted away this concept of creating a queue that subscribes to an SNS topic, and we can just do it in 3 lines. And all the errors that you could potentially make in here, typing this out 1,000 times, disappear. And that leads me to a technical deep dive. I want to start with these primitive modules and look at the complexity of what we can build up using Terraform. So this is going to be quite technical, quite code heavy. I had hoped to build a fully functioning microservices application for this talk, but my kids have been home during lockdown, and I've been quite busy, so I haven't managed to get this all working. But what I want to do is have a bit of a look at how we can take Terraform modules and create complex applications. Excuse me for 1 second while I dig it out. So something that I've done for illustrative purposes is just start off with some primitives. You may want to think when you create your Terraform modules, what you want to do is start with these low-level things. So, for example, how does my company, how do my team want to create an S3 bucket, right? How do they want to create an SNS topic? How do they want to create something as simple as a log group? So I can guarantee you're going to create log groups at some time, which is just like this, an AWS log group. And your compliance team at some point are going to come along to you and say, we now, because of GDPR or PII issues or something, we want to make sure we only retain this data for N days. We want to make sure all of this data is encrypted at rest. This might look pretty basic, but to actually encrypt our logs at rest is non-trivial, right? So just to create an AWS log group that may satisfy some compliance team, you're looking at creating infrastructure to this level. Do that with something like an SNS topic. Yes, and an SNS topic itself is fairly uncomplicated, but we want to make sure it's encrypted. Something a little more complex. S3 buckets have been a massive attack vector vulnerability for a lot of companies recently. They've left their buckets public. Had they taken this approach of creating a generic module for all of their private S3 buckets, and their engineers just use this module, they wouldn't have this problem. So we can bake into our S3. We can say at our company at equalexperts.com, we create all of our private S3 buckets with server-side encryption configured. We use lifecycle rules to make sure that we are cost-effective, so that if a item in our S3 bucket hasn't been touched for 50 days, we move it to some other tier of storage. We can set up public access blocks, so we can make sure that none of the items inside of our S3 bucket can ever be exposed. And in this way, I would really recommend building up these primitive constructs that are used across your whole serverless estate within Terraform. You can then start to build things that are a little bit more fun, right? So in our primitives, we define a lambda function. A lambda function basically just needs a function with a whole set of variables. You'll see that I'm parameterizing just about every parameter possible when I create these lambda functions. So this is a very basic lambda. And I can start to look at the way, what else can I do with serverless? So I want my lambda functions to be able to log, right? Basic 101. Do you remember the example that we walked through earlier? The lambda function couldn't even log. I may want a dead letter queue. So any messages that come into my lambda function that I'm unable to handle for whatever reason can be dumped into this dead letter queue, possibly for handling at a later time. I may want to put my dependencies, so Node.js or Python, Java, Maven dependencies inside a layer, an AWS version. Here I'm reusing another module. So I'm reusing that other primitive lambda function that I created in my primitives folder, and I'm building on that. So I'm literally composing my Terraform modules together. Alarms, this comes back to our production readiness piece. So I've set the threshold at 0 here, so I'm saying if there are more than if there are 0 failures or more, I want you to send me an alarm. Now in production, obviously you would have that set at some greater value. You don't want to get alarms when there are 0 errors, but this is for demonstrative purposes. If I get to it later on in the talk. Oh, that's all I got in here. Potentially to connect my lambda function to VPCs. X-Ray. X-Ray is this distributed tracing solution that Amazon has. And you do need to set up a whole bunch of infrastructure to make sure that your lambda functions can talk to X-Ray. And that's what this is all about. Do I want my lambda function to be able to log metrics to Lambda Insights? That's this resource. Again, yeah, just attaching my logging functionality. Also over here, one big problem with Lambda functions and in the serverless world is this idea of cold starts. So if your functions haven't ran for 5 or 10 minutes, And when they're executed, so when you make a call to an API, the AWS Lambda runtime has to go and grab your code, go and grab your package, has to bring it all into memory, and then it can execute the API request against it. But if we have something like a CloudWatch event rule, so just a cron, so every 5 minutes, we just ping your Lambda function with a dummy event just to keep it awake. And again, this is all parameterized. So Terraform has this idea of how many of these resources would you like me to create? Well, if you've passed me the keep warm parameter, I'll have one of them, otherwise I won't have any of them. Something else cool, it's a bit outside of the AWS functionality. This is one of the upsides of Terraform, is that it's multi-cloud, multi-provider, that it'll support a whole bunch of things. So Snowflake, the analytics database, has this great concept of a snowpipe, which is just a construct that will take a CSV or XML or JSON or Parquet file from your S3 bucket and will land it in Snowflake, potentially doing some SQL transforms on the way. This is a little Terraform module that knows how to talk to Snowflake, knows how to talk to AWS to set up all of the right constructs so that your data flows through into Snowflake. So if you can remember our complex scenario here, this gives me what I want here on the right-hand side. So what I can do is I can publish events onto SNS and go via Firehose to S3. Once they land in S3, because I can configure all of my infrastructure trivially, because I've configured all my infrastructure with these Terraform modules, I then know that my data is going to land in Snowflake, and when the business comes to me and they say, hey Mark, how many orders for customer 7 were made in the last 3.5 weeks because we think maybe there's someone with some fraudulent credit cards, all I need to do is jump into Snowflake and run some SQL and I can get that data back. So how might we use all of this stuff? I've put together this production-ready example. I will commit this stuff to GitHub. So what I was originally intending on building was a service where you guys could ask me questions. I want to have a look at what the infrastructure looks like now. What I've created here are 4 Terraform entities, 4 Terraform modules. So I have a public API. I can pass in my variables like this. I have an API handler, which will be the Lambda function. I have a channel for publishing events. Now, again, this is all it takes to wire this up to send so that when I publish events out of my Lambda function, they're piped all through that convoluted data pipeline and out potentially to Glue, Athena, Snowflake. And I have a DynamoDB table. So I have 1, 2, 3, 4 Terraform blocks and 66 lines of code. If we compare that to the example that I went through earlier, it had, I don't know, 13 Terraform entities and 164 lines of code. You can see the power of abstraction and composition already. And it's no coincidence that these 4 modules map onto our simple example: a gateway, a function, some events channel, and a DynamoDB table, right? API, a function, an events channel, and a DynamoDB table. And so what I've been able to do is do all that work up front by using abstraction and composition to push all of the complexity, to push all of that low value work, that undifferentiated heavy lifting, all that stuff that you don't want your devs doing from day to day. If you remember my slide on the hidden tech debt of production-ready systems, all you want your devs doing is that little blue box of application code in the middle. And that's all they should have to think about to be able to get production-ready services up and running and to build entirely production-ready systems. Helpful tools, and here's where I want to talk a little bit about compliance. So CheckCov, TerraScan, and TFSec. Great static analysis or compliance tools. I've used CheckCov heavily, TFSec not much. I started using TerraScan today so I could have a bit of a play around with it to talk about it in this talk, and it seems probably the best of the bunch. I say that with the caveat of only having a half an hour look at it. I'd highly recommend those tools in your Terraform CI pipeline. This is the advantage of having your infrastructure as code. And you can put these static analysis tools in place, and really to use the phrase shift left on your security piece, right? You can make sure that all your S3 buckets satisfy those rules, that all your SNS topics and all your CloudWatch logs are encrypted with custom KMS keys. And that's really important. And the nice thing about Terraform and the nice thing about using this layer of indirection via modules is that you don't have to think about all of this stuff straight away. If you don't have time to add KMS keys to your buckets, you don't have time to add TerraScan into your Terraform pipelines. By abstracting everything behind modules, you can come back and add those into the modules at a later date. It lets you deliver the functionality quickly, without putting yourself into that hole of having to come back in 6 months' time and go through every single repository, everywhere where you've created a DynamoDB database, and make sure you are using a custom KMS key, for example, making sure everything is encrypted at rest. Some other cool tools, TerraGrunt, that I've used on and off in the past, quite often in Terraform environments, where especially when you're deploying to maybe a dev, a sandbox, a QA, and a production environment. A tool like TerraGrunt can help you out there, keeping you dry. Don't repeat yourself dry. TerraTest, which I've never used, which is a tool for testing your infrastructure as code. And at the moment, I've found the only IDE that really works well with Terraform is IntelliJ. VS Code's getting a little bit better. Yeah, and there's some helpful tools to use. What I'll quickly look at now is some of the AWS operational tools that I mentioned earlier on in the talk, seeing as though I do have a little bit of time. Log Insights has come, although CloudWatch logs have come a long way. When I first started working with AWS, logging was a nightmare. You had to manually go through each log group. So these are what log groups look like in AWS, for those who don't know. Here's, for example, a public API handler. You have to manually sort of go through all of that yourself. Log Insights is actually quite reasonable. You can choose log groups, and you've got some sort of syntax for querying across log groups. Happy to say that I don't have any errors in that lambda function. Quite a cool tool is X-Ray. X-Ray will show you, if you wire it up properly, using something like Terraform module, if you wire it up properly, will show you how transactions flow through your distributed system. So for example, in this case, a client has called my API gateway, pumped that off to the Lambda runtime, to my Lambda function that talks to DynamoDB, publishes an event to AWS Event Hubs, and so on and so on. You can see how it's consumed at the other end by another Lambda function and put into its database. Something that is really quite handy there is you can come in and, so you can see I've got a whole bunch of errors here from trying to debug this today. But you're able to come in and get a decent view of what's taking the most time to handle transactions inside your environment. So I really recommend leaning into X-Ray. I've found it's a fantastic tool. Do that with Lambda Insights. Again, Lambda Insights inside the AWS console, and here is really easy. It's just something you can turn on, which hides the fact of what's actually going on under the hood. You need to install a custom Lambda layer on each of your Lambdas, and you need to set up the IAM permissions for that Lambda layer to be able to communicate with Lambda Insights. And here you can see the various Lambda metrics that you might be interested in. It's pretty cool. A few lessons learned. Serverless is great, but the complexity doesn't disappear. So we need a way of managing all of that complexity. And I would suggest we just use those tools that we know as software engineers of abstraction and composition to build up that complexity, to compose it together like Lego. Use these AWS operational tools. As soon as you step outside of AWS, some other integration point, it's a whole new, if you've got 3 systems that you need to integrate with for your operational tools, it's a combinatorial explosion of how much stuff you need to manage, credentials and the like. System X talk to System Y, when it's all in AWS. A lot of it isn't perfect. I mean, Log Insights is not as good as Sumo Logic, for example. But for getting up and running and getting something that sort of will fit sort of 85% of your use cases, it's pretty good. Use Terraform modules from the start. So don't be tempted to dive in and just start using raw Terraform resource blocks. Now, abstract that all the way from the get-go, even if you're just doing a one-to-one mapping at first. Because you'll find down the track, because you may have 5 microservices that all use the one module, that means there's only one place. You go into that module and that's the only thing that you'll need to change. Compose modules are smaller modules. That's sort of software engineering 101. Do complex things out of small parts. Use sensible defaults. So try and expose as much of the underlying infrastructure as you can through variables in your Terraform modules. And try and get a good understanding of the way Terraform state works. So Terraform, after you've deployed some service with Terraform, Terraform stores that state somewhere. So either locally, which is no good for anyone, or I can put it in S3, for example. You need to have a good understanding of the way Terraform state works when it comes time to refactor your Terraform, where you can really end up in a bit of a bind. I don't want to deep dive too far into that now because it's fairly complex, but get a good understanding of Terraform state. And that's me. Do we have any questions, Matt? Can I hand back over to you?
Yeah, awesome. Thank you for that, Mark. That was really informative. We have had a few questions that have sort of come through throughout the piece, and I'll go through them now. We had Nuno Vargas asked, what type of options are there to integrate the deployment of code with Terraform?
So Terraform will integrate with whatever CI pipeline or whatever CI tool you use. So I've used Circle, Jenkins, Code Build, anything, basically absolutely anything will work. It's not like something like a CloudFormation that integrates really tightly with AWS, but anything that will run a bash script.
Yeah, awesome. Stephen Hodgson's asked, what are the advantages of Terraform over the serverless framework?
Yeah, great question. And an easy one to answer. Serverless framework is fantastic. When I would choose the serverless framework is proof of concept. If you only want to create 1 or 2 serverless services, serverless is great. What serverless lacks is both abstraction and composition. It doesn't let you define those little pieces of infrastructure the way you want them, and then build them together and together and together. It is less complicated. It is easier to get up and running with, but I found that it comes back to bite you when you're trying to use it in larger production systems.
Okay, we've got from Ashish, how does Terraform handle cyclic dependencies?
It doesn't. It doesn't. So you need to make sure there are no cyclic dependencies in your Terraform code. But I think, and I haven't thought about this very hard, but I don't imagine there is a way, if you're talking about just primitives, so the atoms of AWS, the smallest possible things, there's no way that A can depend on B and B depend on A. If two modules depend on each other, I don't know how that would work, because I think what Terraform actually does is it explodes the module out into the various resources. So I think maybe two modules could be cyclically dependent, but don't quote me on that.
From Mitko, we've had, can you suggest some strategies for unit testing the Lambda functions when you deploy with Terraform?
Yeah, just unit test them. So Lambda, the nice thing about Lambda functions is they're just event handlers, right? So, and this is part of a wider conversation, and something where I think I have kind of heterodox views on testing, which is you just sort of want to mock the externalities of your system and test the internal code. So something like the serverless framework will let you spin up AWS local stack, which is a Dockerized version of AWS. At least I think that's the way serverless works. It's been something up like that, or AWS local. I've had real problems with that, with differing behaviors on my local machine and as part of a CI pipeline. Your mileage may vary. But yeah, plain old unit testing. I just want to make a call out to Anton here. I can see his question. Yes, Anton, very familiar with repo, mate, and your presence in the Terraform serverless world. Thanks for everything you do, and thanks for coming along.
In the vein of that, can you see Anton's question? We're asking if you consider.
Exactly, yeah, that's right. So yes, I have used that, and I've also used a lot of his modules for inspiration for stuff that I'm using in production. Which comes back to as well a lot of, so Terraform has a module solution. So if you mention Node.js has npm, and Java has Maven, and .NET has NuGet, Terraform also has a public sort of package manager, or public package registry with lots of modules. And quite often, if those fit your use case, they're great time savers to use straight off the shelf. However, I find, depending, especially on your compliance requirements, quite often you're best off forking those modules and just adjusting them to fit your specific use cases.
Awesome. Powering through. So Johnny's asked, CDK seems to have similar benefits in terms of hiding best practices behind abstractions. Do you think Terraform has benefits that CDK does not?
I presume you mean AWS CDK. Terraform are in the process of building their own CDK. So in terms of the AWS CDK, the benefits of Terraform are multi-cloud, basically. And also personal taste. So I tend to feel, and I've got nothing to back this up with apart from gut feel, that declaring your infrastructure in the way that Terraform does it, as a sort of a declarative language, is just a syntax that I prefer. But I do think CDK has legs, and it's definitely worth investing in. And to be honest, anything that has that abstraction and composition would be great. So yeah, CDK is great. And a lot of what I said here applies to things like CDK, as long as you can use abstraction and composition.
Awesome. Ashish has asked, any comparison to Ansible, which works better?
So I've got to plead a bit of ignorance there. I haven't used Ansible all that much. I believe it's much lower level. From what I hear, I would definitely use Terraform.
Awesome. That's all the questions that came in through the talk. Is there anything that anyone wants to add while we've still got Mark here? So, been a yep, a lot of we've got some thank yous coming in for you, Mark.
Thank you.
Yeah, so we'll looks like we'll wrap it up there. And a massive thank you to you, Mark, and also thank you for everyone who's joined us and asked the questions throughout. If you have any issues or want to dive deeper into the topic for your own organization, please feel free to contact us. We're happy to have a chat and see how we can help. So yeah, while we've got you here, thank you for that, Mark. That was really enjoyable to go through.
Thanks, Matt. Thanks, guys. Thanks, everyone.
No worries. So what's next on the ETO schedule? Well, for the end of September, we have Tony Nguyen, our Director of Transformation and Delivery, and he will be discussing how an organization's funding and budgeting approach can impact its ability to innovate and deliver at speed. Absolutely another one not to miss. For everyone who's joined, thank you for joining in. Have a great day or night, depending on where you are in the world. And we hope to see you at some of our future talks. Take care, everyone.